Good afternoon, everyone. Welcome to
Hello.
Drupal for Gov's March webinar on Journey into Kubernetes. And our speakers for this month are Joel Lehman and Salih Lakhani. So before we begin, I kind of want to talk about, most of you probably know what Drupal Gov is, but we are a community of open source advocates interested in making government more open to open source. So we love all things open source. In addition to these monthly webinars that we hold every third Thursday at 3 o'clock, we also, our biggest event is the Drupal GovCon. And I don't want to talk about the dates. I think we are still finalizing when we will actually host that conference, but once we have the dates finalized, we will let you know. In addition to our conference, our biggest conference, Drupal GovCon, we also do global training days, but due to the pandemic, we haven't been able to do that. As soon as the world opens back up, we will definitely begin. And lastly, we host the Gov Summit at DrupalCon. And I believe DrupalCon is April 2nd through April 16th of this year. So if you're interested in that, please check it out. And if you're interested in contacting us, being a speaker for our webinars, please reach out to us. Our email is drupalforgov@gmail.com. And we also have accounts on Slack as well as Twitter. And so say you miss a webinar and you're interested in a past topic or session, just visit us, check out the YouTube, and after each webinar, we upload the videos. And we also provide information on the Drupal for Gov website on the webinars page, where you can find upcoming webinars. And our next webinar, if you're interested in migrating content into Drupal 8 and doing migrations, our April webinar will be on migrating and all of the tools that are used, and our speaker will be David Cameron. And lastly, but definitely not least, I want to introduce our speakers, our Joel Lehman. He's a solutions data architect at Voice of America, currently working on infrastructure as code, AI initiatives, and search indexing. His background is in data warehousing, database design, and application development. Previously, he worked for the National Agricultural Statistics Service as a solutions architect and statistician. And Salih Lakhani is the CTO and co-founder of DevPanel, the DevOps control panel for Drupal, where he helps companies save money by migrating their sites fully over to the cloud infrastructure within AWS. He's also an ambassador with the Cloud Native Computing Foundation, heads up several DevOps and Kubernetes meetups, and is a founding member of the DrupalOps.com community. And if you're interested in reaching out to him or communicating, reach out on LinkedIn or visit the website devpanel.com. And now I'm going to stop sharing my screen. And you all can take over.
Okay. Can you hear me?
I can hear you.
Okay, very good. Okay, so thank you everyone for coming to the talk. Welcome. Today we're going to be talking about our journey to Kubernetes for both DevPanel and Voice of America. We're gonna go through the talk. As we go through the talk, feel free to put your questions in the chat and we'll address them as we go through. The purpose of the talk is to show you why you should run Drupal on Kubernetes, how you can run it yourself so you can actually benefit from the cost savings. what tools and technologies you can use to get there quickly, easily, and make it painless. And finally, how you can minimize your risks. My name is Salim Lakhani. As you heard, I'm the ambassador. I'm an ambassador with the CNCF, folks behind Kubernetes. Also a founding member of Drupal Ops community. You can sign up for mailing list there and see our events coming up. I'm the CTO co-founder of DevPanel, and it's very much a dashboard like the one you're used to using from the big hosting companies, but we host all your sites in your account. And we like to say we automate AWS and Kubernetes. So here's my contact information if you want to get in touch. With that, I'd like to hand that off to Joel if you want to say, a few words.
Yeah, just glad to be here. Thanks for having me. I think most of my background was covered, but I would like to add I'm a serial technology hobbyist, so I like all things technology. But glad to be here.
All right, very good. So, thank you, Joel. So I'll start off by telling you a little background on. I'll give you a little background and tell you about Kubernetes for folks that don't know about it. So I come from a managed service provider background where we've been managing apps on servers, on VPSs, and in colos for hundreds and thousands of customers since the early 2000s. And in traditional hosting, we run applications on individual servers. And, it's been done this way for what, 30, 40 years now. So this is not new. And, you've heard this, but managing servers this way is like taking care of them like pets, right? So each server is unique and irreplaceable. And there's nothing wrong with running operations like that. But in today's world, you have to ask yourself, is there a better way of doing things? Making sites more fault tolerant, auto scaling with better security, and can we cluster these computers together to make them more efficient and like putting them together like RAID drives, but for compute load. And what about cost? Is the traditional way the most cost-effective way? We all know that that load on sites is never constant, even between day and night, right? So, and from month to month and from week to week, if you have a big event, your load can spike up like crazy, and then the rest of the time you're at a constant roll. So why not scale up automatically for those spikes and then scale down, and just pay for those spikes and why would we pay for peak capacity all the time, right? So those are questions. Those are good questions to ask. Also, from a cost perspective, right? Hardware is expensive and it gets old really fast. So why buy hardware when you can rent it now by the minute? So these were all questions we were asking, and then where does the cloud come in, right? We looked at what's out there and thought, like, what if we could push the SLAs to the cloud service providers? Have them manage the database and the clusters 24/7. Have them do the scaling up and scaling down, and pay only for what we use. And then, we didn't want to manage the hardware because it actually takes a different skill set. So have them manage it, and we can sleep better and go on vacations without any pagers. So, okay. So asking all those questions, we came to the answer that it was we have to use Kubernetes and the cloud native infrastructure. And in this infrastructure and in this paradigm, we treat servers as cattle. And cattle is a metaphor for commodity servers. They're cheap, they're resilient, they're auto-scaling, and here Kubernetes is, the cowboy for the cattle. So this is what Kubernetes does. It manages the servers. It's the orchestration engine for managing a bunch of servers like the RAID drives, right? So with that, this is how we got to Kubernetes, right? So with that, I'm gonna pass this on to Joel and have him give you his perspective on how they got to Kubernetes from his angle. So Joel, you wanna take this?
Yeah, thank you. At VOA, we're always looking for ways to be good stewards of the taxpayer dollar. And, we all know that the budgets can be unpredictable, and we need to be flexible with our infrastructure. And so realizing that, we started researching options, other than the on-prem or data center, or even the traditional hosted cloud solutions. We wanted to move to more of a pay for exactly what you use architecture. And a containerized solution like Kubernetes really seemed to fit the bill. So we started on a journey, and the journey began by creating such an environment on AWS, just using their off-the-shelf CloudFormation templates, combining things like Elastic Container Service or Elastic Kubernetes Service, Aurora serverless databases, all the components like that. And we really liked this idea, and we realized that setting up a Kubernetes cluster was definitely doable, but to manage and control the full architecture gets very complicated very quickly. And to help simplify this, we really saw the benefits of using infrastructure as code that would help us to efficiently manage a complex architecture with a small team, but there were still a lot of loose ends to coordinate. And moving forward to continue our research and our journey, we realized that we had to address several considerations. We wanted to reduce overall costs. The controls had to be very well organized. Every aspect of the architecture needed to be transparent. We needed, tools that made the complex easy to use. And of course, it all had to be secure and supported. Now, cost was probably our number one concern. We want to reduce the overall cost by, like Salim said, not paying for hardware that's sitting idle. And that's all across the architecture. We don't want to be paying for load balancers that are idle. We don't want to be paying for anything that's just sitting there. The development, test, and UAT environments, they should be on demand. You spin them up when you need one, you spin them down when you don't. We don't want to be paying for those just sitting there. We wanted to move to something that is auto-scaling both vertically and horizontally. Scales, spins up more instances and bigger instances if necessary. And then when the load is done, scales down quickly. Our workloads are cyclical, and we shouldn't be paying for the peak 24/7. And we wanted to have the flexibility as well to choose the instance types, depending on the application, whether they were spot, compute, memory-based instances. And as far as control, we were looking to take some of that back by managing things in our own accounts. We want to be cloud provider agnostic, no lock-in. We want to easily be able to move between the different offerings. We don't know what the future holds, so we don't want to be locked into one cloud provider or cloud hosting solution. We want to have root access to all the components, not having to have vendor A call vendor B to fix the issue. Real-time management and monitoring would allow us to optimize in real time and hopefully reduce overall costs that way. And as far as code deployments, they're a huge consideration for us. Whatever infrastructure we're moving towards or has to fit into our CI/CD pipeline, like blue-green deployment, which Kubernetes is very well suited for. The deployments also would need to be fast. We'd need to be able to roll back both code and data quickly. And we're looking for the ability to fully automate or have managed deployments. If you have a new tag in your Git repository, you might have dev and UAT automatically spin up instances based on that tag, whereas production, you would probably want to have a managed deployment. And we wanted to easily be able to use production data for UAT and dev. And with transparency, we want to be able to directly tie a dollar amount to an instance of an application for every part of the architecture in that application. So we should be able to answer questions like, how much are we paying for RDS? How much are we paying for cache or load balancers? The cost should be at this granularity rather than, sometimes you get a bill, a dollar amount per month, or and having this would allow us to do things like take a look at if caching is costing too much. Maybe we need to review and tweak our caching policy. And we should be able to do this by application or site. And that would give management the ability to make decisions with exact information on that site. How much is that site costing? So moving on to ease of use, we're a small team. So whatever the solution we are headed towards, it has to be easy to use. So creating new environments should be fully automated, completely documented, and repeatable. And that goes for both the Kubernetes and the cloud environment. We don't want to have people have to edit templates on the command line. The management of the application and sites needs to be simplified, and this should include data management, like point and click copy of a database, clone a database, backup a database, that sort of thing. And we also really need the ability to have both logically and physically separate sites based on project requirements. We want to be able to do things like putting a site's physical location in an availability zone that's as close as possible to the audience. And security. Security with government is paramount. And using infrastructure as code really simplifies things when it comes to audits and accountability. And not only that, there's also a lot of third-party tools that can provide automated security reviews, things like AWS Inspector, just to name one. All the components we use would have to be FedRamped. So things like the relational data store or Elastic Kubernetes services or the load balancers, they would all need to be FedRamped and should also be FISMA compliant and in accordance with the risk management framework process defined by NIST. And, disaster recovery and KUB, they should all be baked into whatever solution is provided. Having multi-availability zones with auto failover, that should all be default. And, the backup schedules and backup infrastructure should all be part of the infrastructure as code as well. So with all these considerations to sort of continue our journey, learning more about, how to run Kubernetes on cloud native, we really decided that those were the two things, those were the must-have. Had to be Kubernetes, and it should be cloud native infrastructure. And that checked all the boxes we were really looking for. Cloud native gets us as close to the source without actually having to manage servers. Like Salim was talking about. We don't want to manage pets. We just want to have commodity instances of the servers. And Kubernetes was going to give us a scalability, security, resilience, and ease of deployment, and provide flexible environments for like dev, test, and live. You know, it becomes much easier to spin those up. And so how do we get to this utopia? Well, we've made part of the journey and uncovered some, I should say many obstacles along the way. But most of you have probably seen the Drupal learning curve cartoon. Well, the Kubernetes learning curve is about the same. So you could imagine the learning curve for Drupal on Kubernetes. We wanted a solved puzzle. We were asking questions like, is there a blueprint for a complete pre-built solution, or is there somebody who knew how to set this up and how to manage things? And that's sort of where we connected through the Drupal community with DevPanel, saw what they were working on, and seemed to have a lot of the features. So we got in touch with Salim and have been continuing a journey of discovery on how to run Kubernetes and Drupal. I'll turn it back over to Salim.
Okay, thanks, Joe. So at DevPanel, we've been working on the control panel for a while, and we've been we automate the control panel, and we automate AWS and Kubernetes. So we run applications like Drupal, WordPress, Magento, and any application on over Amazon and Kubernetes. So and why? Because AWS is hard and Kubernetes is even harder. So, and what we do is we set up a cloud native open source infrastructure in our users account, letting them run applications like Drupal, WordPress, and we configure everything to auto scale. We even configure the clusters to use spot instances and save them money, up to 90% on their AWS fees. And as we build out our application, we solicit feedback from organizations to see how we can improve. And that's how we got connected with VOA through the Drupal community. And they've helped us a lot in developing some great features and functionality already. So our goal is to fully automate infrastructure setup, application management, log management, CI/CD, daily things like backups, monitoring alerts, your deployments, day two operations like security updates to Kubernetes, patches, underlying system patches, and then give the tools to manage costs and billing to our customers so that they can do that themselves. So with that, let me play this little video to give you a little background on DevPanel. Hi, let me tell you about DevPanel. With DevPanel, you get a point-and-click, easy-to-use control panel with pre-built applications that you can launch with a few clicks, create as many dev, test, live environments. It comes with browser-based development tools like Visual Studio Code, so you can work from virtually anywhere using any PC with no need to set up local dev environments. You can manage all your projects, clients, and sites with just one DevPanel account. Because all your sites are in your own AWS account, you're just paying for the dashboard. And depending on how many sites you're running, this makes for a huge cost savings. You pay AWS directly, and you pay them for only what you use. Plus, with DevPanel, your sites are running on AWS's enterprise-grade infrastructure that almost all big companies rely on. It's auto-scaling and fully managed by AWS, so your infrastructure will hardly ever go down. Best of all, you don't need to know any AWS to use DevPanel. So welcome to DevPanel. It's a new way to develop and a different way to pay, and it will change how you work forever. So with that, I'll actually, let me go to the next slide and give you a quick tour of DevPanel. And this will show you how it actually works. Here's a quick tour of how DevPanel works. You can start by creating a workspace and linking it to your AWS account. This is as simple as logging into your AWS account and running a CloudFormation template. After the two accounts are linked, you can start defining the infrastructure you want. Select a region and specify the size of your Kubernetes cluster, nodes, and database. You can even tell us if you want to use spot instances and auto-scaling. If you don't know, these can save you up to 90% on your AWS bills. It takes about 15 minutes to create the database, set up the Kubernetes cluster, spin up the servers, and configure the account. Once the infrastructure is set up, you're ready to set up your project and create your applications. Here, we'll start by creating a new Drupal project. For a new project, DevPanel will automatically create a repo for you and set up develop, release, master, and main branches. You can then build applications on any branch you want. Here, we'll build out the develop branch using all the defaults. When the application is built, you'll get a URL for your application and tools to develop that application. All development tools in DevPanel are browser-based, so you don't need a local dev environment anymore. Because it's all browser-based, there's nothing to download to laptops and your code stays secure in the cloud. For developers, we've got both PHPMyAdmin and VS Code IDE running in the browser. VS Code even comes preloaded with Composer and Drush. With this setup, you can ramp up new developers in less than a day. And that's how DevPanel automates AWS and Kubernetes. Okay, so with that, I will walk you through the 5-phase checklist that we ended up developing working with some clients. And this will help you kind of de-risk your implementation plans on going to the cloud. So here's the cloud migration checklist. And I'll walk you through this and I'll give you the PDF for this in the chat shortly. So the 5 phases that we've identified, and this is still a working checklist. So I'll send you the link to the document as well as the PDF. So if you have comments on it, please feel free to collaborate with us on the document too. So the 5 phases are, phase 1 is the discovery, where you identify and take an inventory of all your applications. You define your apps and the usage for your apps, identify any dependencies, which can be other applications or any compliance or regulations. The phase 2 is assessment of different ways to migrate your application, and you'll have to build out internal and external team like DevOps, development team, your migration and support teams. Identify systems and tools, define your RPOs and RTOs, define any operational requirements like security, compliance, auditability, your SLAs. And then this is really important, is to do a proof of concept. We do this with all customers. You identify and de-risk your risk factors. So and then you want to deploy your typical workloads, and you test your migration tools and services, test your deployment tools and workflow. You're going to test your dev test live environments. These are done all in your account. So make sure your account works. You're going to do your load testing, performance testing, security, scalability, everything in your account. Do deployment, rollouts, rollbacks, and do cost estimates in your account so you can see how much it'll cost you if you actually go live. And then document the whole migration process and create your infrastructure as code scripts. This is what you would use to do the migration. So then you can automate this repeatedly. And this is what DevPanel uses as well. And this is what DevPanel actually creates for you. And these are all open source scripts that we give to you. We use Terraform and CloudFormation for these. Then we test failover and disaster recovery. Phase 4 is the actual migration where you create the production environment and test the infrastructure creation with scripts, test your application deployments with scripts, backup recovery. All of this is done with scripts. And then you're documenting your processes and procedures, and you're educating your developers, your users, everything using your migration platform, your application that you just migrated. And then before you launch, you want to soft launch it and do your user application testing. And this is just testing over again, making sure everything is working. And then when you go to launch, we recommend that when you launch, you run 2 things in parallel, at least for a month. And this way you can monitor the new site for not just for performance, but for user experience as well. And if there's a problem, you can just flip the DNS back over and have the old site running. So just be prepared to roll back, and that's the safest approach. There's a little bit about DevPanel, and but the most important thing here is that we love to collaborate with folks, and this is how we learn and we give back to the community. And we're building out open source tools on AWS and Azure to automate site migrations to cloud native architecture, to optimize performance, to save costs. And this is being done on AWS and Azure actively. So if you have any interest in that, then let us know. Here's our contact information. So let me put this in the chat.
Okay. You also have questions. Someone also asked if you could share your slides too as well.
I can do that as well. So let me see what the chat is. I don't have the slides ready just yet, so I can do that with Nika. Can I do that with you later?
Yeah, and I can post it to the Drupal for Gov webinar.
Okay, perfect.
Yeah.
Okay. All right, and then here is. Do we have time? Yeah.
Yeah.
So let me. This was my backup. So I'll show you how we can do. Let me show you how this auto scaling stuff works on AWS and Kubernetes. So you'll find this interesting. This is where you end up really saving money on your infrastructure. So, okay, so let me play this. Hi, in this video, you'll see how DevPanel handles auto scaling. You can see here that we're starting with 3 servers in our cluster here. And in our DevPanel account, we have a bunch of projects, each with their own dev test live branches, but we haven't built any apps yet. So let's go through all these projects and build out all the branches at once. This should put some stress on the cluster. Let's see what it does. So we'll click, and start building all these apps. If we take a peek at the deployment process, we can see a bunch of tasks running here. A few minutes later, we'll see that our apps are built out now. Let's go back and check to make sure they work first. Here's Drupal. Let me check if I can log in as admin. And let's see if phpMyAdmin comes up. And let's see if VS Code comes up. Okay, let's go back and take a look at the cluster. We'll refresh this page and let's see if the number of servers in this cluster has gone up from 3. Yep, sure enough. We're now at 7 servers, 6 of which are spot instances. These are transient servers. They should go away when the load goes down on the cluster. So let's shut down our dev instances and the other sites that we had spun up earlier, and let's see if that makes a difference. These servers should go down. Okay, I'm going to start shutting down these sites one by one. I'll fast forward through this. And there, all our apps are being undeployed right now. We'll have to wait here a bit until this is done. Let's take a look at the cluster now, and we'll sit here and start refreshing the page. We should see the server count go down. Yep. Okay, we're down to 4 servers. That's 1 more than we originally started with. And this is normal because the system is waiting to see if it's going to get any more unexpected load suddenly. So it wants to be prepared for that. But soon enough, it'll most likely go down to 3 servers again if it sits here idling for a bit longer. Okay, that's it. We've now seen how DevPanel can set up your cluster to automatically scale up and down in your own AWS account. Contact us if you have any questions. Okay, so that was that. Let me go back. And there's a bunch of questions. So if there's questions, if you have any questions, please list them. I'll go through the questions. There's already some questions from Ray. There's a question how easy it is to set up a Solar instance. We can set up a Solar instance. It's just an application. So you can set that up as an application, in a cluster, or you can use Amazon Cloud Search, Elasticsearch, whatever. So
It's flexible.
yeah, it's flexible as to what you want to use. And again, it's your account, so you can look up how, how Solar is set up, and we would just implement that as an application. You would just deploy that as an application from DevPanel. But if there's a managed service, we always recommend that you use a managed service in Amazon. And the more managed services you use, the more SLAs you're pushing to Amazon, the less you have to maintain. So you're paying, sometimes you're paying a little bit extra for a managed service, but you don't have to worry about it. So that's the most beneficial thing, and it's, trust me, it's pennies compared to what you're paying to hosting companies today for managing that service for you, because they're in turn, you know, what you're paying to your hosting companies, they're in turn using using Amazon and using GCP and using Azure on the back end anyways. So they're using the same stuff in the back end. So why not just use those things directly and cut out the middlemen? So are there any challenges, current challenges hosting Drupal on DevPanel? I don't know what you mean by challenges, but no, we scale really, we've integrated Varnish, Memcache, it scales really well, you know, to thousands of users, concurrent users, and a ton of traffic. Works with CDNs and things like that. In regards to comment, we are researching around. Okay. How does it handle app upgrades? It's through, what you would do is for application upgrades, if you're doing upgrades for Drupal, you would just branch it out and try out the upgrades in your different branches. And if that works, you would just do a pull request and pull that into the master, and then you can do tagged deployments. We didn't look at any of the deployments here today, because then you have to get into the whole Kubernetes deployments and blue-green deployments and things like that. We just didn't have the time.
How about
So,
MySQL and PHP upgrades?
oh, it's similar. So you can do you can run PHP upgrades on a different branch, and you can take a container and you can just, these are run in containers. So you can run a different version of PHP in a different container. For MySQL, what we actually don't run MySQL in containers. We run RDS, Amazon RDS, Aurora, which is the Amazon managed version of MySQL. So we would just create a different database with a different version of MySQL, and then you can connect to that with your containers, with your application. So instead of connecting to one database, you connect to the other database, and then you can test it out. So it's very easy to do that. And that's done through. Go ahead.
The RDSs are really nice.
What made you choose Kubernetes over AWS's Elastic Container Service in their registry?
I don't know, Joel, you want to explain the difference, like what you saw first before I go through it?
What we saw first is it gives us more control, and we read somewhere or learned something that the EKS is actually scales better.
Okay.
Yeah, so not only does it scale better, but ECS is more server-based, and it's AWS proprietary technology. And EKS is based on Kubernetes. So we do use EKS, which is Amazon's managed Kubernetes service. So it is Amazon managed Kubernetes, but it's based on the Kubernetes service, which is not proprietary to Amazon. It is a more agnostic service. So it's very generic. You can, and it scales very well. There's a lot of tools out there. There's Helm charts out there for different applications that you can download. You can launch applications on it really fast. There's lots of tools out there like Prometheus, Grafana that plug in directly into it. So yeah, so it's very scalable and very open source. So EKS is also based on standard. Yeah. Thank you, JD. Yeah. Other questions?
So there's a question about how about backups? Does DevPanel do scheduled backups for you?
Yeah. So we take care of the backups, and then like you can set up, you can define your backup schedule and rotation, and that depends on your policy of doing backups and retention. So we'll take care of those. But yeah, and then for restores, that's up to you. So. And we give you cron jobs. So there's a whole thing for doing cron jobs, and you can set up cron jobs to do whatever you want, basically. So. How many developers per account? There is no limit. You can, it's your account, so you can choose as many developers you want in your account. You can bring in other agencies, you can bring in whatever you want. So any other questions on, you still have some time if you have questions about VOA, DevPanel, Drupal on Kubernetes, AWS in general, Kubernetes in general. Yeah, I sent a link to the PDF and the document above in the chat. So if you scroll up on the chat, there's a link to the PDF and the document. And oh, it's for the direct message. Sorry, I sent it, I think, just to Nika. So let me send that out to everyone. Okay, now I sent it to everyone. So there's the document for, if you want to comment, the document that I had shared earlier, this checklist. You know, this is everything we do, we consider work in progress. So there's no egos involved. So if you have any comments, if you have stuff you want to add to it, we're happy to take your input and add to it. Oh, good question about Jenkins. Yeah, so we can bring in Jenkins, but we actually can run this. You should take a look at drone.io. Drone.io is automated. This is a CI/CD system that actually runs. It's a 12 megabyte Go application that runs in Kubernetes. So it scales much better. It's lightweight. It can actually run in your cluster, and it is really lightweight because Jenkins is heavy. You know, it's heavy. So yeah, so we can run Jenkins, not a problem, but we recommend you use Drone.io. We use it ourselves internally, and it works like a charm. And if you go to, a lot of people don't know this, but if you go to plugins.drone.io, it has a ton of plugins. So we really recommend this to everyone because it can actually run in your cluster. It can auto scale in your cluster, and it's cheap. It's cheap. So because it's really lightweight. So take a look at Drone. And Jenkins is not a problem. So if you have Jenkins stuff, you know, we can run Jenkins. We use Terraform, Ansible, CloudFormation, all those things we use out of the box. So, and Drone. So, anyways, what
I
else?
think we had a question on percentage decrease in costs by switching.
I don't know.
That's a very, I can't really say, but it's really hard to say because we don't know what type of platform you're sitting on, you know, whether it's on-prem or, you know, data center.
Yeah,
So,
it's we'd be happy to talk to you because, you know, we're essentially charging you for the control panel, and you're paying for AWS directly. So if you want to run a sample workload on AWS, you can try it out and then see what it costs you. You can run it for an hour on peak and then on regular load, and you can just extrapolate from there and see what it would cost you. So.
and I see a question about our cost reduction of VOA. We're still in the research. We have not implemented, so we're strictly just figuring out how this whole thing would work. And, you know, it's been a collaboration experience between DevPanel and VOA, and we're learning as we go. But you know, so far things look very promising for, you know, a Kubernetes architecture.
And at the same time, we love to collaborate, and you know, it's not about the sale. It's about us. It's about the learning, and if we can learn from something, and if we can grow from it, and if it helps you, then great. There's a question for VOA here.
We're using a hosted cloud provider.
So.
And there are several architectures.
Okay, so thank you, everyone.
Yeah, thank you.
So, yeah.
Yeah, thanks, everyone.
Such an interesting topic, especially since everything, a lot of the government agencies are moving to the cloud. And so infrastructure as code is also important. So
yeah, and I hope people found this useful. So yeah.
Thank you.
Thanks.
All right. Thank you everybody for joining. See you in April.
Bye.
Bye.
Thanks, Nika. Thanks for the opportunity.
No problem.